there is a some kind of formula. I think it's still best to think about it visually over here, right? If you want to find the probability of A given B, that's A given B, right? That's equal to this. I mean, think about this formula, right? So A given B. So go back to this one, right? A given B meant that I'm looking for A given that B is true. I'm looking for this shaded part given I have this red circle. And Angus was telling me that the sample space was changing. What's the sample space of A given B now?
2.
Yeah, it's 2. Or in set notation, it's just B. Right? So P of B, that's our new kind of sample space. That's what's going to go in the denominator. But what am I actually looking for?
A and B?
Yeah, A intersection B. And that's our formula for A given B, conditional probability. Shut that down.
Lit.
Alright, so we have this idea now and we formalized it, right? What we did is when we see A given B, what we want to think about is, hang on, alright, the sample space is being restricted, it's being reduced, right? What's it being reduced to? Well, if it's A given B, P of B is my new sample space, and the intersection is probably that particular thing occurring. So here, right, we've seen this kind of situation before. We've got 75% chance of hitting a first bullseye, 33% chance of hitting both. We want the probability that he hits both, not just that he's hit both, but we've got some other information that changes the probability, given that he's already hit the first one. Okay? So it's very important that we see that distinction, that giving us extra knowledge changes the probability of an event occurring. Right? So what's our new sample space with this one?
Hell yeah.
75%.
Right, so if I have this guy as A, this guy as B, okay? Maybe you want to be careful how you write this one, right? So, given that this one is true, given that this one is true, so which one's actually given to us? A is given to us in this situation. Okay, so if I'm just labeling these sets, right? So the way you write it does make a difference as well. So this would be P of B given A. So I'm saying that, okay, what's the probability that he hits both of them, given that he's hit the first one already? Okay. So both of them happening, that's 33%, divided by the probability of this guy here, that's 75%.
44%.
Probability of B.
And that's just 33 or 75. What's up, Laura?
Wait, so
Yep.
in these types of questions, should we always go back to 4, like the answer of 33 over 75 is 0.44, which is 44%.
Yep.
Should we display it as 44% because they use percent, or if we display it as a fraction?
Both would be acceptable. If you're going to round it, just make sure you round it. They can present the information in different ways, right? This particular one, they've given us a two-way table. And you have to be careful with this conditional probability because sometimes they sneak in questions which you don't really have to use that at all. Just read the question carefully. I've got 100 people in total here, and they're telling us that we've got some people who are vaccinated and not vaccinated, but you can still become infected even if you are vaccinated, depending on the type of disease and stuff like that. Yeah, it's a zombie apocalypse, right?
You against the being vaccinated?
Nothing. It's good to
You're an anti-vaxxer.
be vaccinated on particular things, right? So not vaccinated. How many people are not vaccinated here? We've just got 57 as our total.
57, damn.
Yeah. And what's our total?
100.
100. So it's 57 out of 100.
1, 2, 3.
But now we're starting to be given some information.
Per minute.
What's the information that we're given? Well, we're given that they are vaccinated. So that's restricting our sample space, Laura. We're given that they are vaccinated, right? I'm given that they're vaccinated. What's the probability that they are infected? So I'm told that the people I'm choosing, they're the vaccinated people. What's the probability that of those vaccinated people that they're infected?
So over 43 is that?
How'd you get that?
Well, there's 12 people infected
Yeah.
in the vaccinated,
Yeah.
and then there's 43 in total.
Okay, so can you see, if you're giving information in a two-way table, don't necessarily have to use this kind of formulaic way of doing it. You can kind of just observe it from there. How do you realize, hang on, of these people who are vaccinated, there's 43 in total. 12 of them got infected. That's 12 out of 43. Just to show you though that you can still use this in this situation, right? Just think about what these represent. Think about what is P of A intersection B in this situation, right? P of A intersection B is, okay, infected and vaccinated, right? So that would be infected and vaccinated, there's 12 of them. That's 12 over 100. So this is A and this is B. What's the probability of B? That they are vaccinated, right? That's what P of B is representing. And P of B is 43 over 100. So if I was to use this formulaic way of doing it, P of A intersection B divided by this, can you see how you'd still get 43 over 100? You can still use this way to do it, right? Both of them still work, but if you have the table, the information is a bit easier to digest. Because if you put 12 over 100 divided by 43 over 100 in your calculator, you'll end up with 12 over 43. Okay? So whichever way you find easier, if you like using that table to interpret the information, or if you like using this kind of formula that we've developed, you can do that as well. Callum, next one. So we know that they're not infected. Oh, sorry, we're given that they're not vaccinated, sorry. So they're not vaccinated,
So it's
and they're not infected. Yeah, that's right. That's how sample space is being reduced.
Yeah, 7 over 57.
Okay, so 7 over 57, awesome.
Oh yeah.
And last one for me.
Laura.
Yeah, go Laura.
It's 12 out of 62.
How'd you do that?
Because they're infected and there's 62 people infected and the vaccinated ones are 12.
Okay, so here we've got 62 people that are infected and vaccinated, there's 12 of them, so that's just 12 over 62. So I think you guys would agree that it's much easier to try and do these ones using information from the table, right? But sometimes we can't do that. Sometimes we're given things like this, or we have to interpret the information ourselves.